The Appalachian Mountains, stretching from Alabama to Canada, are among the oldest mountain ranges in the world. Their rounded peaks and forested ridges may not tower like the Rockies or Himalayas, but they tell a story of geological time on an epic scale. Formed nearly 480 million years ago, the Appalachians were once taller than Everest. Erosion wore them down over eons, leaving behind the rolling green ridges familiar today. For centuries, geologists believed the mountains were stable, their violent past long gone. But new satellite data has shattered that assumption. In recent months, scientists detected sudden and unusual uplift across sections of the Appalachians, movements that triggered a rare red alert in the geological community. The breakthrough came from INSAR, or Interferometric Synthetic Aperture Radar, a satellite-based technology that measures ground shifts with millimeter precision. By comparing radar images over time, researchers can detect even the slightest changes in elevation. In late 2024, scientists noticed something strange. Portions of the central and southern Appalachians were rising unexpectedly. In western North Carolina, uplift of 3 to 5 millimeters per year was detected, far above normal erosion adjustment levels. In parts of West Virginia and Virginia, ground movement was uneven, with patches of land bulging upward in wave-like patterns. Some areas of Pennsylvania and Tennessee showed microfractures in the crust consistent with rising pressure below. Individually, these might have been anomalies, but together they formed a picture of a mountain system that was restless once again. The United States Geological Survey and independent researchers use a 4-tier alert system to communicate risks. A red alert is the highest level, signifying unusual geological changes with potential consequences for ecosystems, infrastructure, and human communities. The alert did not mean an imminent catastrophe, but it signaled that the Appalachians are undergoing processes scientists don't fully understand, and that monitoring is critical. As one geologist explained, "We don't issue a red alert lightly. It means something extraordinary is happening in the crust beneath one of the oldest mountain ranges on Earth." So, what could cause such sudden movement in an ancient, supposedly quiet mountain chain? Well, several leading theories emerged. First, there's isostatic rebound. As glaciers melted thousands of years ago, the Earth's crust has been slowly rebounding upward. But, the current uplift is faster than models predict. Second, some scientists suggest deep mantle flow. Hot, buoyant material from Earth's mantle could be rising beneath the Appalachians, pushing the crust upward. Third, hidden fault activity. Even though the Appalachians aren't as seismically active as, say, California, ancient faults still cut through the region. Subtle reactivation of these could be influencing uplift. And fourth, hydrological stress. Changes in groundwater storage, perhaps intensified by climate change, might be redistributing pressure underground. No single explanation yet fits all the data, which is why the red alert emphasizes vigilance. For many, the Appalachians conjure images of quiet forests, Appalachian trail hikers, and coal-rich valleys. But the range has, a turbulent past. Ancient collisions. The Appalachians formed when continental plates smashed together, creating supercontinents like Pangaea, and earthquakes too. While not frequent, the region has experienced notable quakes, including a magnitude 5.8 in Virginia in 2011 that cracked the Washington Monument. There are even volcanic roots. Evidence suggests parts of the range were once volcanically active in deep geological time. The sudden uplift reminded geologists that these gentle mountains still carry the scars, and energy, of their violent origins. The satellite findings sparked both curiosity and concern across Appalachia. Local officials in North Carolina and West Virginia began consulting engineers about infrastructure monitoring. Bridges, tunnels, and pipelines that cross shifting ground could be at risk if uplift accelerates. Environmental groups raised questions about how uplift might alter watersheds, river courses, and forest ecosystems. Residents, hearing the phrase red alert, expressed unease, though scientists reassured them this was not about imminent collapse or eruption. One resident near Asheville, North Carolina said, "We've always thought of these mountains as solid, unchanging. To hear they're moving again, it's humbling." Some researchers see a link between modern climate pressures and the Appalachian uplift. The last ice age ended thousands of years ago, but its effects linger. Melting ice sheets removed weight from the crust and rebound continues today. Heavier rainfall and rapid groundwater extraction for agriculture and industry may, subtly alter crustal pressure. And changing weather patterns could accelerate erosion, prompting the crust to adjust upward more quickly. If true, the Appalachian Uplift could be one more way Earth's deep systems are responding to human-driven changes above. Leading geologists and seismologists urge caution but also awe. Dr. Hannah McBride from the USGS says, "The Appalachians are reminding us that no mountain range is ever truly asleep. They may rise slowly, but the processes at work are powerful." Dr. Rajiv Menon at Virginia Tech adds, "This is less about predicting disaster and more about deepening our understanding. The red alert is not a warning of doom. It's a call to pay attention." And Dr. Elise Moreau from the University of Toronto observes, "The patterns we see suggest forces beneath the Appalachians are more dynamic than we thought. This may reshape how we view ancient ranges worldwide." If the uplift continues, what might it mean in the long run? Well, streams could shift, wetlands might drain or expand, and species that depend on really precise habitats could face disruption. Roads, pipelines, and railways crossing the mountains may need reinforcement or even redesign to handle these subtle shifts. Uplift could also affect coal seams, shale deposits, and even geothermal prospects. And a rethinking of mountain stability worldwide, from the Scottish Highlands to the Urals, may be necessary. Though these changes are slow by human standards, over decades and centuries, they could be truly transformative. Beyond the science, the red alert carried an emotional weight. Mountains are symbols of permanence, anchors in cultural memory. To imagine them rising again unsettles that sense of stability. For Appalachian communities, the findings became a reminder of resilience. Just as the mountains have endured for hundreds of millions of years, so too do the people who live in their shadow. As one local teacher put it, "Maybe these mountains aren't as still as we thought, but they've been through worse, and are still here. That gives me hope." The Appalachian findings resonated far beyond North America. Scientists compared them to uplift events in the Alps, where glaciers' retreat has triggered rapid rebound. In the Andes, where deep mantle activity lifts entire plateaus, and in the Himalayas, still rising as India presses into Asia. Together, these events highlight a universal truth. Earth is not a static globe of rock. It is alive, restless, and constantly reshaping itself. The sudden uplift of the Appalachians is not the end of stability, nor the beginning of catastrophe. It is a message that the Earth's story is still unfolding, even in the oldest of its mountain ranges. The red alert serves as both caution and invitation. Caution, because we must watch carefully. Invitation, because it reminds us of the wonder in paying attention to the ground beneath our feet. The Appalachians, once thought to be fading relics, are stirring again. And in that stirring, humanity is reminded of its place, not as masters of the planet, but as witnesses to its ongoing creation.